name is Kelly Kane, and I'm the Marketing Manager for E&M. Thank you for attending our S7-1200 Modbus TCP Webinar today. If you haven't, be sure to check out our other upcoming webinars at enm.com. This webinar is on August 23rd, called PLC Programming Best Practices. You can register and find more information about this webinar on our website. After this morning, we will be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or email us at enmwebinar@enm.com. I'd like to introduce your presenter for today's webinar, Bill Hinn. Bill has been working with Siemens Automation Products for 25 years as both an OEM machine designer while at James River Dixie Products, and also with Agilent Technologies as an engineering manager. Currently an E&M Siemens product specialist working with customers to design new applications for Siemens products. Good morning, Bill.
Good morning, all, and welcome to the Modbus TCP webinar. Today we're going to be using the S7-1200 processor to implement Modbus TCP and the Siemens third generation of the TIA portal, which is version 12. The 1200 shown here is actually the latest version of the S7 product line. There's also now the 1500, which is actually its big brother, which is also configured in the new TIA portal version 12. Just to let you know, anybody that wants to get a hands-on look and feel for the version 12, we have a roadshow coming up. So let's go over and look at the E&M website, enm.com. From here, we can actually go into the workshop schedule, and you'll see here that we've got at the end of September and early October a 10-day, 10-city roadshow that's going to be covering the TIA portal using version 12. Version some neat new features, including integrated drive configuration, something called Start Drive built into it, which is a neat new feature. It also, as I mentioned, will program the S7-1500, and you'll see one of those in the room at the roadshow as well. This is a hands-on half-day workshop, and everybody that gets a chance to go to that in one of the 10 cities coming up will also have the opportunity to get some hardware to take home with you at a Siemens discounted price. Back to the subject of the day here. We're going to be doing communications in the S7-1200. The 1200 is actually quite a communications powerhouse in that it has lots of different options that we can use. All the new 1200 and 1500 processors have built-in Ethernet ports with standard RJ45 connections. So the programming cables and the serial ports on laptops that are getting hard to find are kind of over with the 1200 series. And it allows us just to use standard Ethernet cable to plug into your laptop and go out in the field and work on a PLC. There's also some expansion capabilities on the 1200, including Profibus. There's an Aussie interface module, which is kind of a neat power-end communication network for push buttons and actuators and that kind of stuff. There's serial modules available. In fact, one of the major applications that we see with Modbus is that we have a lot of Modbus serial still out there. And with the 1200, we can add a serial module and talk to all the Modbus RTUs, they're called, and those in and put them up on Ethernet using the built-in Ethernet port and Modbus TCP compatibility. So a neat option for us. Bridge modules and so forth that are available commercially are usually much more expensive than buying the PLC and a serial card. We'll also talk a little bit about functions and how we actually integrate these different protocols into the PLC itself. Having said that, let's go ahead and jump into, I'm going to pull in the TIA portal here. And what it is, if we can, this is called the portal view. And within the portal view, it's kind of a jumping off point from which we can go into any of the different features of TIA portal. here I've actually got the installed software showing here, so we see that I'm on version 12, update 3, and so on. And we can go through, we can open an existing project, we can create a new one, which is the first thing we're going to do today. We can migrate older version software. We can go to a welcome tour, which is actually kind of a how-to on different parts of the TIA portal. Help file online, we can go jump in just, if we're just out on the field, on the plant floor or whatever, and we've got a red light on something, we just hit the online diagnostics and pop it up right online. So what we're going to do today is we're going to actually create our own project and start from scratch here. So I'm just going to call this webinar. The defaults in there and hit create. This goes ahead and gets us started out with our project. It's still going to leave us in what's called the portal view, but the portal is going to change here a little bit and then give us a screen that gives us what are the first steps that are available to us for our new project. We could configure a device, which we will. We could go to writing programs if we wanted to. Configure technology objects. Those include things like PID and motion control. We could do a screen. Here's something new in 12 is parameterized drive. This allows us to go online with different drives and parameterize them and bring them up. Or what we can do is we can open the project view. First of all, let's configure a device. Let's actually put a processor into our project. It's up showing all devices in the project. We've just started it, so there are none. Let's go new device. And what it does is it gives us a screen with the different possibilities for controllers. See here, since I have the full-blown TIA portal version, it has all processors available to me. HMI, we could add an HMI touchscreen or whatever. A PC to the project, or version 12 is we can add drives. But the first thing we're going to do today is we're going to add a S7-1200. And if I click on that, it gives me the CPUs, all the different flavors of CPUs that are available. And the third, at this point, comes in 4 different flavors, the 1211, the 12, the 1214, and 1215. The comes in 3 different electrical configurations. So in other words, I've got a 1211 AC-DC relay, which just means that it's powered by 110 or 220 volts. It has AC 24-volt inputs and dry contact relay outputs. There's DC-DC 24, 24, 24. There's the DC power, DC input, dry contact output, and this pattern repeats itself for all the different 1211, 1212, 1214, and 15. We're hearing 17 coming soon. Let's just go pick a middle-of-the-road guy. DC, 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 why not? Anyone will do for the software configuration we're going to do today. I'm going to go ahead and click that and click Add. And we're all that in the processor into the project. It's also going to jump us into what's called the project view. So as we've got that guy in there, it shows a photorealistic version of the PLC itself. So here we see this is the view. And with project view, we're going to always have the same type of a look and feel. On the left is going to be what's called the project tree. And we're going to actually have our workspace. And then on the right side, we're going to have a context-sensitive area. So in other words, if I'm doing a hardware configuration, as we jumped into now, it's going to give me all the different options of hardware that I could add to this processor. For example, if I wanted to add a Profibus module into the CPU, then actually it gives me the different flavors here. There's a select module and a master module. If I click on it, it tells me which slots it can go into. In the case of the 1200, it's kind of a unique feature in that it puts any communication or specialty modules on the left side of the processor. And why? It's so use up any of the I/O areas to the right side. So in other words, I can, if I click on a digital input module, those are available to go on the right side. And if I do, again, the module, it can go on the left. Everything is, for the most part, drag and drop in the TIA portal. So I just dragged over a master module, and now I've got a, you'll see the green port there is the Ethernet port, or Profinet, which is actually, Profinet is the implementation that allows us to do distributed I/O and so forth over an Ethernet port. And then the one is actually Profibus. I look at the window area, I see up on above I've got a device view tab, and then network view actually allows me to see everything that's in my project from a network perspective, connected together. You'll notice that my catalog has changed here. Now I've got things like distributed I/O available to me. I wanted to add a distributed Profinet node ET200 Eco, for example. Let's look at a digital input module. I put it up into network view. See, it says not assigned. That's because this is a remote I/O node. It needs to have a master to actually control points. How do we do that? We just put that little green port and drag to the Profinet port of the PLC, and now I've actually configured my distributed I/O. I do the same thing with Profibus. So in other words, if I wanted to actually look at the type of I/O module, but in a Profibus version, I go over. Now we do the same thing, not assigned, with a purple port on it. Just drag that up to the purple port. Now I've got an S7-1200. It's a master on 2 networks with 2 remote I/O nodes. Let's go ahead and make sure we're happy with that. Compile. This is just a good way to check to make sure I haven't made any mistakes. Everything came up fine. So this is kind of an idea within the portal how things work. You're going to have a project tree, a work area, and then a context-sensitive area over on the right side, in this case a hardware catalog. We also, over on the project tree now, we've got this PLC included and some distributed I/O nodes and so forth. But within PLC, I can go in here and look at the program blocks. And so the exercise for today is to do Modbus TCP. Let's go ahead and look at give me main organization block for the PLC. So OB1 in Siemens World, organization block 1, organization blocks are called by the processor. So in other words, OB1 just runs automatically in the background. So anything that is working in a PLC can be programmed in OB1. There are benefits of doing that from a structured programming standpoint, but I always use OB1 just as a standard PLC programming area. On a plant, let's say we're going to make a conveyor, just a simple one. And one of the things that I mentioned was that we can actually create, Siemens can actually create other blocks and so forth within the programming area. And one of the ways of doing that is just to add new block, and we see different types available. I mentioned organization blocks, and there's different types that are called by the processor. Like the OB100 can just run on startup. So anything that you want to preset defaults on and so forth, you can run an OB100. So we're just going to make a simple subroutine so we kind of differentiate different areas of our program. And look, we've got a conveyor system. So I'm going to name the function conveyor and hit OK. And what that's over here in the project tree, you'll see I've got a function call conveyor and the same type of programming environment, because this is a subroutine. It uses same languages and so forth. On the right, I now have an instruction list, and all the different instructions that are available to me come up on the right-hand side. There's this area here. You'll see if you put things up here, it shows up above. So if you've got some instructions that you like to use a lot, you can actually insert them into the favorites area. Ones for communications and so forth, and we'll get into those in a moment. But as far as our conveyor system, let's do something simple, and let's just say we want to count the boxes that go by on a conveyor. And in order to do that, we're just going to use what's a standard counter, and the counters can be found in the basic instructions here. You can actually use like that at count up, CTU count up. That's going to be a data that pops up along with it, so that it has a place to maintain the memory of how many counts we've done and so forth. To remember with the TIA portal is if I hide an object and hit F1, it's actually going to give me some context-sensitive help. Let me go in then. Up here, what's the counter function? So with her, it gives me examples and the past parameters and so forth. So I'm going to go into that counter module, and I those just what we're doing with our project. So counter, anytime the count up leg here pulses, it's going to count up. So if I wanted to actually have a counter counting boxes, I might want to put a box go by, and as it pulsed up and then off again as the box went by, we would count up. Reset we'll deal with in a moment. The PV is the actual preset value. So let's just say we wanted to count to 50 boxes. Counter value coming out is actually where we are at any time on our count value. This Q, and Q stands for it's an output area. So I'm going to actually put an output coil on there. After we've reached our set point, we can actually turn on an output. And maybe this would be a light or something. We could call it conveyor full. You'll notice here that we've got some red squiggly lines underneath these defined tag names, and the reason for that is that we actually really haven't defined it. We just typed it in. It didn't recognize it as something it knew before, so it's going to give us the squiggly line. If I right-click and tag, I can actually assign that to an address. So in other words, internally we've got memory areas, and the default would be M0.0. So that's memory byte 0, bit 0. That would be the first memory bit. In our case, we're going to want photo I to the PLC, so I'm going to put I for input 0.0, and that would be the first input point. See, I've done that, and it comes up above the tag name and says what that actually is. I can do the same thing over here with the output, so we can call that Q 0.0, and that would be the first output. Now, a portal uses a common database for its entire project, so actually when I'm doing things like this, it's going to create with all these tag names and so forth. And if I were to go back over and look at my device configuration and zoom a little bit, I/O points, they actually show up now on the processor. So it's actually just a kind of a to let you know what's going on within the database. There actually keeps track of all this, and this would be true of a drive or an HMI screen or anything else in the project. It's going to have this common database, which is one of the powerful functions of the TIA portal, in that you don't have to redefine things every time you create something in one device. It actually propagates throughout the whole system. Anyway, let's get back to our conveyor. This conveyor, it's actually been out there counting boxes and running along for months and months, let's say, out on the floor, and suddenly we hear that there is a new SCADA system coming into our plant. And a SCADA system is supervisory control and data acquisition. That's actually typically a large-scale information system for a plant that actually is going to go out and interrogate all the different devices on the floor, and they have standardized on Modbus. And they're going to use Modbus TCP to actually implement the SCADA system throughout the plant floor. And so come to us as the plant engineer to say, okay, we've got Modbus TCP, how are you going to do it? And so I'm going to click the conveyor block in OB1 so we're sure that actually we're running this block. And now that I've done that, what we need to do is add Modbus TCP to this. So let's talk a little bit about Modbus. Modbus is Wikipedia on Modbus. And Modbus was a protocol that came out in the 70s, and actually they did something fairly unique in the automation world, in that they published the entire spec for Modbus. And Modbus was therefore kind of as a standard for several different industries, including water and a lot of municipal type applications. And the is actually, it really has a supervisory SCADA type system, and it has remote nodes, typically called RTUs, or remote terminal units. So supervisory control means that we're going to be giving commands to intelligent devices, and the actual real-time implementation of those commands is actually handled at the node level. So in other words, an RTU is going to get a command from a SCADA system to say run recipe 1, and then it actually implements the recipe 1 locally in a real-time control system. The supervisory thing is going to say do it. The RTU is going to actually do the work. The other part of SCADA is data acquisition. So it's actually going to get reports from all these distributed nodes as to what the status is in the field. So in other words, we're going to use a combination of SCADA and RTUs, and oftentimes this is what the original applications were for things like levels and wellheads and that kind of thing. So we would have a lot of distributed nodes out there, oftentimes on radio, at fairly low speeds and reporting back to the SCADA system. So it isn't unheard of to have a 10-minute update for up to 240 devices at, let's say, 300 baud. It's time to go through these one at a time. It's a polled routine, so it goes through each individually one at a time. Modbus over the years has several different variants. So in other words, there's Modbus was the original type of system it used, and Modbus RTU or binary came out, which was a little more efficient in the way that handled all the bits that were communicating back and forth. And what we're talking about using today is this Modbus TCP, which is based on Ethernet. And we're seeing a lot of Ethernet-based distributed I/O protocols and so forth. And in addition, with the 1200, we've got a built-in Ethernet port and programmable to handle different protocols. So that we do a implementation is I'm going to create another block here so we can actually differentiate the functions again, and we'll just call it MB TCP, so we'll know what we're doing in there. And when I come up and give us another blank slate of ladder logic networks, And within this Modbus TCP, we can actually look over here under communications. Available communication types for us is Modbus TCP. TCP comes in the form of a client or a server. The client is typically the SCADA system, and the server is actually what we're going to be using today. So in other words, we're going to make a remote unit that's actually going to report to a SCADA system. And it's going to pop this, it's going to ask if we want to have this data area defined, and we're going to say OK. The Modbus server to have some internal data area for the configurations that it needs to do. Now, hit F1 here, I'm going to see our Modbus server is going to be able to do for us. So let's go ahead and look in here and see different pass parameters that are going into our block. So the first one we see here is a disconnect, which if we wanted to turn it off, that's how we would do it. The second one is called a connect ID. Connect ID is actually just needs to be a unique number so that actually the Modbus client actually knows who to pull. We can be a server to several clients in a 1200. All we need to do is to have a unique connect ID. So I'm just going to call this one 1. The IP port is pre-defined for Modbus TCP, so we don't have to mess with that. Holding register is actually a user-defined area for Modbus, and we're going to talk about that in a second. But right now, let's go ahead and look in our server and see what we've done by just calling that block. Since we put parameters into there, right now what's happened automatically is now when a SCADA actually pulls our 1200, it's going to automatically map these different address areas into Modbus registers. So thus, Modbus register 1 through 8192 are going to be outputs 0.0 through 1.3.7. So that's already done as soon as we call the block. Input thing. Modbus registers they call 10,000 registers input areas. 1,000 registers in Modbus are typically analog inputs, and they're going to be pre-mapped in automatically. And outputs, there's actually some ways of writing multiple bits and so forth, and these are just Modbus function codes, but they're going to the same addresses. And so that we've actually already implemented to a certain extent Modbus. The thing left for us to do now is what's called the holding registers. And the holding registers, as I mentioned, are user-defined areas. So if I go ahead and do a holding register, by clicking on holding register, this is going to actually request to put a pointer into where is the data area that the holding registers are. So in other words, internally to the 1200, there are some memory areas called M words, M bits, words, and so forth. And they're of all of the 1200s, they exist in there. So a way to do user-defined data areas, data blocks, and we'll do that in a sec. But now let's just go ahead and grab this pointer. The pointer goes to MWord 100, and it's going to set 5 Modbus 40,000 registers. I'm going to go ahead and call that and paste right into this pointer. So what have we done? We've actually created a complete Modbus server call into our PLC. I can actually do that. We still need to call it. In other words, we are conveying run. Now down here, our Modbus. So there we go. We've actually implemented Modbus. Right now, all the inputs and outputs and any analogs are being automatically mapped into our SCADA server. We have created a data area that's going to have the holding registers, but really haven't put anything into them, so they're all going to be zeros at this point. Let's go back to our conveyor and see how we might want to put some holding registers in there. So I have a reset, which is going to be actually a bit, and we'll deal with that in a moment. But the preset value and the current value are things that would be a good idea to have Modbus registers for. So let's look at a different way. I mean, oftentimes what we like to do, and we do this in the best practices webinar quite a bit, is to create what's called portable code. And portable code really means nothing more that we don't use absolute addressing in it. We actually create our own addresses so that we can implement portable code into an existing application without tapping on any pre-used areas. So in other words, what we might want to do here is rather than using Modbus code, this word, which may very well be used in our existing project, let's create what's called a data block. And a block with a name, holding registers. Block, it can be used anywhere in the program. And it gets a bit of a different configuration area in that what a data block is we're just going to use some of the internal memory of the PLC to create our own data template for whatever data we want. In our case, we're going to put an array of registers for Modbus holding registers in the 40,000 range. So I'm just going to call this 40K, so 40,000 registers. And then I'm going to create an array. That is, we're going to create an array that goes between, let's say, 1 and words. Now I should be able to open this up and see that we've created 20 internal words that we can use for Modbus holding register areas. So 40,001 through 40,020. Let's go with that. Now go back to our Modbus program. Our pointer from where we were pointing at static addresses, we change that now to, if I type in the first letter, it's actually going to predefine which ones I want. For A, the first one in our data register area is where we want our pointer to go to, so 40,001. So we created our data template for all the holding registers, so if we use this Modbus server in any future project, we're not going to have a problem. What else do we need to do to implement our Modbus TCP? We mentioned that we wanted to use the preset value, current value, and put that into Modbus. So if we're to do that, I'm just going to go back into holding registers and say we want 40,005 to be the for our counter. Current value that we could read to the SCADA system, 40,006. Could be anything we want in there. Then effectively mapped in these two variables into Modbus. One that we may want to do, I mean, if you look at the way our logic is right now, this thing is going to count up to 50 boxes or whatever we have now in our holding register. And it's going to turn on the light, and that little light's never going to turn off. So we want to put a reset in here, and that could just be a that we could trigger however we want. But if we wanted to do it for Modbus, it's kind of an interesting concept is that if you remember, we can mention the inputs and outputs from the SCADA system. We can also do a little trick in that we can use an output that doesn't physically exist on the PLC. So maybe I want to make this we'll call it reset. as Q2.0. There are 20 bytes of outputs on that PLC, we know that, but that internal queue is really it's an image table. So in other words, the physical I/O doesn't have to exist, but we can still use the bit. So in other words, now we've got a Q20 set that reset. So we can counter back to 0 by turning on Q20 from the Modbus system. Okay, that all makes sense? All right. We talked a little bit about this is something, as I mentioned, we go into more detail in the best practices, but we see a lot of hard-coded I/O points in here. Our function call is an area called a declaration table. We can create past parameters in here. So what does past parameter mean? If we look at our block here, when it gets called, there's nothing into it except for turning it on and passing power through it. Let's change that a little bit and make this so that we've actually got past parameters into this block so that maybe we have multiple counters and we want to use this over and over again. So make that OI as a past parameter now. We have reset. Output is full. We've actually got parameters that are passed into this block. So I can actually go in here and say, type in P, and it gives me two options. It gives me the one that we used originally with a hard address on it, or hash marks in front of them are actually past parameters. So now I can actually create, what do I is that contact element. I can do the same thing with my full, with version. So with my reset, I'll save that. Go into where we called this block, which was OB1, and now we've got a complaint here. It's got a red around our function call. And why? That's because we've changed the interface of this block. And if I click on it, we look at updating it, and it gives me, hey, this is what last time we called this block, but now these past parameters in there, is it okay to use those? And I'm going to hit OK. So we have past parameters into our actual conveyor block. We can actually now put in our and now it gives us the capability of calling a block multiple times and so forth, which is actually a handy feature. There's one issue that we need to deal with on the KO, but to do that, you're going to have to watch the best practices webinar. So let's talk a little bit about what we've done today. We've actually originally we brought in PLC. Profibus module just so we could show we could do it, but really not required for this project. We have some distributed I/O and so forth just to get an idea how communications work in the TIA portal. And what we did is we went in and added a OB1 call to our conveyor system with a Modbus TCP server, and we created a block with registers in it. During our little exercise today, we've actually got some questions that came up. Let me take a look and see what we've got here. Oh, I've got some V12 questions. Okay. I had IA version 11 service pack 1. How can I get V12? That's a good question. easiest way to do that, and that would be to call E&M. And actually, there are several different programs that SIMS has for getting those versions of software. So we call 866-693-2636. There's right now a program from Siemens available to get us all the way up from those of you who may be still on version 10.5 to version 12. And that's kind of a time-limited one. So if you're on 10.5 and you want to get to 12, call that number and they can help you out. Okay. Next one is another V12 question. Program my original 1200 with V12. Yes, you can. The 12 actually allows us to program any of the prior versions of CPUs. And if we look to here, when we select the processor available, it gives version numbers and so forth. So we could pick a version 2.2 or a version 1.0 or whatever it is that we're actually using. The other option is just to go online with it and let it figure out what you've got, and then it pre-populates your project with any version you've got. Okay. Next question is, I have a machine coming in with a comfort panel. What is that? Well, that's a good question. Comfort is a term that comes from Siemens for several different products, and one of them happens to be a HMI system. So if we look at the Siemens over the years, they've actually had several different types. There used to be the 170 series, the 270 series, the 370 series. With the newest panels, we now have what are called the base panels, and we also have something called the comfort panel. The comfort panel is pretty neat. These are the newest, latest, and greatest panels from Siemens. They've $1 million. They're very vibrant displays, all LED backed, and this is the latest and greatest. So you just pick which one you've got, and we take a look. There are panels that actually have keys around them, touch panels, and then if you're going to, actually you can program these to go in portrait mode, so they stand up that way. So that's what a comfort panel is. It also programs in TIA Portal. Okay, you guys can send them in via the email link that we discussed earlier. That's it for today's Modbus TCP. We look for that roadshow coming up. That's going to be a good one. So thanks all for coming, and Kelly, yours.
Okay, Bill, and thanks for everyone for attending. If you would like to review any portion of this webinar, a recording will be available on the website enm.com by Monday afternoon. And again, if you have any questions that come up after the webinar, feel free to email us at e&mwebinar@enm.com. And thank you everyone for attending. Have a good day.